I didn't do that. Okay, finding lesson 3.6. There are two parts to this, so we'll have to see where you're at on that sheet. Actually, I think it's the lower part that we'll be doing today. And then we'll go back to it tomorrow to finish it up. So kind of fitting in some different sections here. Okay, we're going to focus on lines today and figuring out whether they are parallel, perpendicular, intersecting, or coinciding. So I think it's more direct to the bottom part of your notes today. But there are three forms, and the notes up at the top, I don't think I mentioned standard form up there. So why don't you write yourself a little note above that chart when it tells you what standard form is like. Slope-intercept form and point slope form are there. We have to have all those different forms for different purposes, I guess. Standard form is the one that is used if you're trying to do a vertical line. And for your standard form, they usually use capitals. It's AX plus BY equals C. In that type of an equation, the X and the Y are both on the left. Think about maybe the bell ringer or the worksheet. I put that form on some of those problems and had you rewrite it. Do you need notes? If you have a permit. Otherwise, I'll give you a blank one and you can fill it out. Okay. On standard form, usually there are no fractions in it, but the X and the Y are both on the left side of the equation. Slope-intercept form, which is in your notes, and we'll work on this more today, y equals mx plus b. You're used to that one from algebra so that you can see the slope and the y-intercept. Point slope form will work probably more on tomorrow. Y minus y1 equals m, x minus x1. Now each of them are used for a certain purpose. And we're going to today try and switch from one form to another form because the form that we can analyze a lot from is slope-intercept. So if an equation is in standard form or in point-slope form, we'll probably convert it into slope-intercept form so that we can analyze whether the lines are going to intersect, be parallel, or if they're really two of the same, as in coinciding. So that's the different forms. Slope-intercept, as I said, that's the one you're familiar with. M is the slope, so that's going to be a number, and B is the y-intercept, where it's going to cross the y-axis. So be sure and add yourself some more notes about it if you need more explanation. So if the slope, which is the variable m usually, the slope is 3, B represents y-intercept. In this form, the equation would just look like y equals 3x plus 6. So we'll either start with the slope and the y-intercept and make the equation, or once we have the equation, then we'll say, okay, now looking at that equation, what would the slope of that line be? What's its y-intercept? So that we can do some comparing. Okay, let's see if you can do some graphing. Back of your marker board does have graph. If you'd rather have an actual graph paper so that you can have more for your notes, you can grab that. And I think I'll get out some straight edges so that you can draw better lines. We'll get out some long rulers. Who's going to want a ruler to draw with? Maybe are good doing one now. More rulers wanted? So how do you graph that line? Well, if all else fails, make yourself a chart where you pick an X and substitute it in to see what the Y is. But probably the easier thing that you did in algebra was, what does this number represent? Slope. And that is rise over run. So if your slope was 1/2, from one point on the line, you're gonna rise 1, and then you're gonna run to the right 2, but you have to know where to start. Lines don't always go through 0, 0. So where do you start this line? It's not really where it begins, but at what point? What's this? Y-intercept. So that is on the y-axis. That's where this line is going to cross the y-axis. So that's a point that we do know. So locate that point on the y-axis. From there, do your slope, rising and running. Rise would be up. Run, if it's positive, you go to the right. The way I usually do the positives and negatives, if there's a negative involved, I associate it with the rise. So instead of going up, I would go down. That way I'm always running to the right, and I don't get myself confused. So where does it look like it crosses the x-axis? Is it -2? I think I've got a picture here probably. Okay, that's a section of the line there. Crosses the y-axis at 1, rise and run, and you extend the line. Looks like it crosses the x-axis at -2. Just a refresher from algebra. Okay, let's try another one. About y equals 2x minus 3. Now remember, you're graphing lines, so they keep going to the left, they keep going to the right. Oops. You haven't drawn a line, you've done some steer steps. Okay, your line should be crossing the y-axis at -3. From there, you went up 2 to the right 1, up 2 to the right 1, so it's hitting the x-axis somewhere between 1 and 2. Maybe it would be 1.5. Question on that one? Okay, so now I want you to try to think if I want this on paper. Yeah, I think I want this actually on graph paper. Might be more with it than just do it in a race. You will need some graph paper for your homework. See if that was enough or not. So graph the line that goes through those 2 points. Through that point, that slope. I gave you a variety of ones to graph. So make a graph for each one separately. Yeah, let's do each one separately. So if we do more with it, you don't get them mixed up, which is good. So divide your paper into 4s and fold it. Divide it into 4s. Or if you want to go half and then use front and back. Third one, I noticed the y-intercept is going to be -10, so that one needs to go down, by the way. Now your x and y-axis don't have to be exactly at the center of each fourth. You can adjust it depending upon what numbers you notice. Once you see that someone around you is done, compare your graphs with the neighbor. On negative, I would say always associate the negative with the top number. So that would either go up or down. The bottom is always going to the right. Always going to the right because the bottom is always the positive. So again, compare with the neighbor. See if they are slanted the same way, going to the same point. The crosses at -2, and then the slope is -3 down, so down 3 to the right one. Clarifying that I need to do. This should be reviewed, refresh your memory. Anything I need to say to clarify some things as you're comparing and graphing? Okay, if not, if you didn't get the last ones, write them down, and if you need to. The last two were similar to what we did earlier, so perhaps you reviewed it, okay? But I want to go on. Okay. Horizontal lines and vertical lines are kind of special ones because of their slopes. The equation of a vertical line is going to be x equals something, and the example up there is x equals 5. Now you might want to add yourself just a little graph picture beside that. What would it look like if you graphed x equals 5? X equals 5. X-axis, y-axis. If x is equal to 5, that would be like graphing the point 5, 0, 5, 1, 5, 2, and so on. You would get a vertical line if you graph x equals 5. What is the slope of that? It's so steep we can't define it. Undefined. I think you had those notes somewhere else. And then a horizontal line, the slope of a horizontal line is 0. So you might think of this as y equals 0x plus 2, but it just simplifies to be y equals 2. That's going to be a horizontal line going this way. Your points would be like 0, 2, 1, 2, 2, 2, 3, 2, where the y is always 2. So those are a couple special ones. When we look at those, they're horizontal and vertical lines. We'll probably touch on that again tomorrow. All right, we need to get to the analyzing part, which is at the bottom of your notes. Okay. We are going to take two, let's skip over that. Skip over those. Okay, we're going to take two lines and decide if they are parallel, if they're perpendicular or intersect, or if they coincide, like if it's two copies of the same thing. So from something we discussed the other day, slopes of parallel lines. If two lines are slanted the same, they're going to be parallel. What's their slope going to be? It's got to be the same. To get them to slant the same, the slopes have to be the same. A perpendicular, one going this way, one going the opposite way, not at just any kind of angle, but it has to be at 90 degrees. What's the relationship of those slopes? Remember what we came up with? Flip back, was it section 3? Okay, it had reciprocals, and define them. Was it 3, 4 maybe? Was 3? The last page? 3, 5? Yeah, 3, 5, down at the bottom. Parallel lines theorem, perpendicular lines theorem. Okay, perpendicular lines theorem said they would have opposite signs and be reciprocals. If you would multiply them, they would be -1. So that was in section 3.5. I think that's part of what's on your list. Okay, we're going to take two equations and analyze whether the lines are parallel, intersecting, maybe they're perpendicular, or coinciding. Coinciding means it's two copies of the same line. And we're going to try and do this without having to graph them all the time. So here's what you're looking for your notes. Parallel lines will have the same slope but different y-intercepts. They will be slanted the same, but they're going to hit the y-axis at different locations. One's going to be higher, one's going to be lower, that kind of idea. So an example would be y equals 5x plus 8 and y equals 5x minus 4. The 5 is the slope, so they have the same slope. They're slanted the same. Their intercepts are different because they will hit the y-axis at different places. Intersecting lines, not specifically just perpendicular, but intersecting lines are simply going to have different slopes. If their slopes are different in any way, they will eventually cross. I did an example where one's positive, one's negative. They don't have to be one positive, one negative. But just as long as they're different slopes, they're going to intersect. It doesn't even matter what the intercepts are. And I put a note here, they could be perpendicular if they intersect. That would be your opposite reciprocal type of slopes. They're different, but they would be special different ones if they're perpendicular. Now, coinciding, what that means is the same line. Remember an assignment I told you, if you think that they're parallel, you better graph them to see if they really double up, if they're the same line, if they're different lines. Here's that idea again. So coinciding lines, they're going to have the same slope and the same y-intercept. So everything about them's the same when you put them in this form. Now, if the equation is not in the form that I'm showing here, we need to do what we did on the bell ringer, change it from the form that I give you into slope-intercept so that you can quickly analyze. So that's going to kind of be the algebra part of what you have to do. Okay, finish with notes. Okay. Determine whether these lines are parallel, intersect, or coincide. You can decide, but then get your marker board and write it on so I can see everybody without you telling. So are they in the form that we can use to analyze? Yes, you want to learn y equals mx plus b. Now look at the notes that you just had. Are the slopes the same or not? That'll give you one idea. And if that doesn't tell you enough, you would need to look at their y-intercepts. Pick out the slope of each one and look at your chart. Are they the same? Are they different? And go from there. You don't have to graph them, just have to analyze that. Do you get those notes down? What to do? Okay, so just decide based on what the slope and the y-intercept is. Okay, show me. Okay, I see quite a few intersecting. Some of them had parallel. Intersecting is correct. Now they're not parallel because the slope of this one's +3, the slope of that one's -3. If it's positive 3 and we graph when they go up to the right, but if it's a negative 3, it's going to be going down as it goes to the right. They're not going the same direction. So that was intersecting. Were they going to be perpendicular when they intersect? Are those opposite reciprocal slopes? They're opposite signs, but they're not reciprocals. So they would intersect, but not at a 90-degree angle. Okay, on this one, are they parallel, intersect, or coincide? The first one is in a good form. The second one's not. So you might take that second equation, 6y equals negative 2x plus 12, divide by the 6. You get to say y equals. Once you change its form, you can analyze them better. You can solve. Let's say y equals is negative 2, 6 reduce. Yeah, make that negative 1/3. And then 12 divided by 6 should have had a 2 at the end. So, divide by 6. Right, so here was my original equation. Here's the one that converted into. Okay, some of you are ready to show me what relationship already. Okay, what are they? Show me. Okay, good. Parallel. Parallel lines because they had the same slope, negative 1/3, but their y-intercepts are different. This one had a 5 for a y-intercept, this had a 2. So they're going to hit the y-axis in different places, but they're slanted the same. Okay, next ones. Determine whether they're parallel, intersect, or coincide. Neither one is in a good form to analyze. So take this first equation, get it into slope-intercept. Take the second one and put it in slope-intercept. Did you see why I had you practice doing that earlier? Now we're needing to know how to do that. Okay, show me what you came up with. I think some are finishing up. Sorry for listening. These should be coinciding. When you get those two equations converted, they should have been identical. They should have both been 2x plus 8. If you're not getting that, you made an error somewhere in the sequence there. And most of you did catch, yes, they have the same slope, but they also have the same y-intercept. So that was coinciding. All right, let me show you some that are converted. So these two, second equation is kind of hard to tell. There's the first equation converted. Here's the second equation converted. Compare the two equations and tell me parallel, intersect, or coincide. So you're just analyzing right now. Show me on your board. Parallel, intersect, or coincide based on those two equations. Do they have the same slope? And if they do, then you need to look further. Do they have the same intercept or different intercepts? That tells you parallel or coinciding. Show me. All right, these should have been parallel. They have the same slope, but different y-intercepts. Okay. And the last quick little idea is, how can you determine if two lines are perpendicular from slopes? We discussed that. Okay, they have to have opposite signs and reciprocals. And horizontal and vertical lines, remember, are perpendicular. This is one, I gave you two of these on your homework, where you have 3 points. They're going to form a triangle. You don't have to graph it, but you could. Without graphing, determine whether it's a right triangle or not. Well, what's a right triangle? Triangle with a 90-degree angle. Can we tell from slopes whether there's a 90-degree angle? Yeah, if we have some that indicate perpendicular. So if there's slopes that indicate opposite reciprocals. I think I did the calculating here to speed us up a little bit. I probably shouldn't have had the complete solution. But when I calculated using A and B, the slope was 3/2. When I used B and C, the slope was -7/4. When I used A and C, the slope was -2/3. So how did I calculate the slope? The third formula down, slope formula, not midpoint, but slope. Y2 minus Y1 or X2 minus X1. If you need to, write it in your notes again. Slope formula. Okay, so are any of these slopes opposite sign and reciprocal? And notice the positive 2/3, positive 3/2, and negative 2/3. Those are reciprocals and opposite signs. So those two are perpendicular. So if segment AB was perpendicular to segment AC, you can figure out that A is the right angle because that's where they come together. So you'll have to do some slope calculations and then see if there's any perpendiculars. So there's 2 of those to try to intersect. All right, I said we stop with about a half hour. That's where we're at. So you will need some graph paper for your homework. If you don't have some, there's some by the next box here. Okay, we'll do 5 through 11, 16 to 22, 33 to 36, 41, and 42. Thank you, Tina.